Assalamu everyone, and today we'll be starting linked list. And before I start linked list, I want to show you a file that I've uploaded in the drive folder so that it will be beneficial for many of us, because this is a file to test the modding. Remember, in circular arrays we did use the mod a lot. So this part, this start plus size, and then start plus size, mod circular length. So I gave you a file where you can test out this mod thing. You can create, change the start, change the size, and then change the length as well, and then use this file to check the mod. So it's a little handy thing. You know, sometimes we're even busy to write this code, so I gave it to you. Okay, so today's topic, that's all for this file. And one more thing is, keep updated with the drive folder, because I upload stuff there almost every day. I update many files in it for various courses, so try to keep updated with this. Today's topic is linked list. Okay, so let me get my pen. Linked list is the thing we're going to do now. And what is a linked list? Before I tell you what linked list is, know this, that circular array was not a built-in thing, right? You did not have something called circular array in the real Java, but this linked list, you actually have it in Java. You can get this linked list by importing. Remember, we import scanner? You can import and get this linked list just by writing import linked list, and then you can create a class of linked list, and then you can use it. So today what we're going to do is we're going to learn how that linked list is structured in Java or in any other language, but we'll be implementing Java for this. So there's a head, as you can see over here. There is a head, and linked list consists of two things. Linked list is a class, and each class consists of two things. One is the data itself. So you can say it could be an int, it could be a string, it could be an object, it could be anything. Another is a reference data type. That means if my class is link L, then there will be a data type of this format which will have the address of this, which is another link L class, L class. This is an L, this is an L, this is an L. Say this is L1, this is L2, this is L3, this is L4. So L1 will have a data of itself, and also it will have the data or the address box of L2. That means L2 will have the address box of L3. L3 will have the address box of L4, and L4 won't have any address box, so there won't be anything left after that. This is the primary idea of a diagram idea of a linked list. So if there is a question in your mid and final to draw a linked list, this is how you draw. Okay, and these values will go on, and if it's a circular linked list, then you know what to do. This will be here, so there won't be any end if it's circular. Okay, that's easy. Now let's go to the coding part. That's all for understanding. So first thing we need to do is create the first linked list, which we call node. So let me go ahead and create that. What did I tell you? Linked list have two features, two things, right? The first is a data type. It could be an int, double, whatever. Let's just use object so that it can take anything. Okay, object data, object element, or whatever you want to rename it. Element. If you want to compare it with arrays, then I will use this. And the next thing I told you that it will have the address of the next one. So L1 will have the address of L2. To have that, he must have a space where he can keep the address. So this is the space. So we're done with creating the node class. Now you can go ahead and create a constructor as well, which will be taking an object E and a node, and I can see the mistake I made. The constructor will set the values. Next we'll have n. That's with the node class. Now let's create our linked list. So we'll be doing a lot of things with this. The first thing we need, I told you that there must be a head. That is the point from where the linked list will start. So if we have a head, we have the whole linked list, because head has the address to the next element and the next. Then suppose the link, assume the linked list I showed you at the beginning of the video. So if L1 is the head, L1 has the address of L2, L2 has the address of L3, L3 has the address of L4. So if you have L1, you have the address of L2, L3, L4 automatically. So that L1 will be the head. So we need to have that head. Creepy. Okay. So we're done with this. Now we can go ahead and create our methods. So one common thing that we are asked, and you might be asked, is that convert an array to a linked list. That is the most common thing to do. So let's go ahead and create that. Obviously it will receive an array, so we'll have that. Okay, now before I explain anything, I think it's better if I just write the code. So in head we'll create the first node. I'll start calling it node now, so gotta get used to it, which will obviously have the first value. And I don't want to put any address at this moment, so I'll just keep it null. You do remember the constructor, right? First is the element and second is the address to the second one. But for now I'm keeping the address bar empty. Now I cannot change the head, so I need to have a tail or something so that I can move through the list. I need to move through the list from one point to another. For that I need another node which will change. But if I change the head, I lose the linked list, so I cannot change the head. Okay, that's an important concept. Why can't we change the head? So we'll have another copy of head with the name tail. Now we'll run a for loop, which will obviously start from 1. Why 1? Because we already have set up the value of 0 index in head, which had the value of 0 index. So there's no point of starting from the beginning of the array, because the first value or the first space was already created. So we'll start from the second. So it will start from 1. This doesn't change, it will obviously go until the length is covered, and we need to put the increment. Okay, so now that we have the array loop, what are we going to do? We have to go through the array, at the same time we have to go through the list, and at the same time we'll have to put the values. So to do that, let's create something that will continuously be created. That means a node that will be created every single time, because the list is not like array that you press a size and that number of space, or number of, what should I call it, slots will be created. So those slots are not created. In a linked list, you have to create each slot by your own hands. So one part is that it has infinite space, it never ends, which was an issue and a problem in array. Okay, now that I'm mentioning it, let me tell you some things about array and linked list. So an array takes a lot of space, it takes a fixed amount of memory, and even though the array is not full, that memory is still covered. So that's the first problem with arrays. So if you have 8 slots of memory, and the size of the array is 8, it will take those 8 slots, which is a problem. Another problem of array is it cannot be resized. You can resize it by creating another array, but that's not the resize we know. We want to increase the slot, we want to decrease the slot. That's not possible in array. You can empty, you can add, but you cannot change the size of the array. However, in linked list, you are the one who will control the size of the array. So that's a huge advantage of linked list. Another advantage of linked list is it doesn't take memory simultaneously. So once you create a slot, it takes a slot in the memory, and when the time comes and you create another slot, it will at that time take another slot in another memory slot. So these are the two major advantages and disadvantages of linked list and arrays. But one primary disadvantage of linked list is if you lose the head, you lost everything. And if one part from the linked list is lost, the rest is lost as well. That's not the issue in array. You don't lose anything in array. And the second thing is putting values in linked list is a problem. You have to go through the entire linked list to put the values, which is not the case with the array. You can just have the index number and then place the value in the array. Okay, so that's all for linked list versus array. You will have that conceptual question in your finals. That's why I discussed that. Now, let's keep talking and coding. So we will have this node created every single time, and every single time I want the value from my array to set, and I don't want to do anything with the address bar right now, just to keep things simple. Now the tail.next. So at present we are in the first slot, so the next, which is the slot that will hold the address for the next node, I want to keep temp over there. I just created a new slot, and there I'm connecting with this. Okay, so I will show you what happened here by drawing. Let me just finish this. And then I want to increment tail, so tail will become tail.next. Probably none of this is making any sense. Let me make some sense out of it. I want to take this color. Okay. Now, understand where we are at now. We created a head. So this is the head. It has 2 boxes. And we created a tail which is the same. So let's create tail over here, which is just as the head. Same thing. For now they are equal. And we created a for loop, and that doesn't matter. What matters is we created another node temp, which has the value of the second. So if my array was 10, 20, 30, 40, head has 10, so tail has 10 as well. This is the 0 index, this is 1, this is 2, and this is 3. Oh my god, horrible handwriting. Can't help it guys, I'm using the mouse. So we created the node temp, right? So we have temp over here, which will also have 2 slots as usual. Now AI is equal to 1, which is this. Okay, and when I created the temp, I said that the value will be A of I, the value of the second index. So temp will have 20, right? No confusions over here. Now tail dot next equal to temp. Whose tail now? I told you they are the same, right? Head and tail are the same for now. So tail dot next. So this slot will have the address to this slot. Why both of them are having it? Because tail is still equal to head. This part is still valid. It has not changed. So both of them will have the address to this. Now tail is equal to tail dot next. So this new node is now tail. So this tail is no longer existing and it has been destroyed. So head, but however head still has the reference to this temp, right? Head is not destroyed. Head still exists over here. By using tail, we put something on head and then we change the temp tail to this. Now this temp is equal to tail. Then when we increment the loop, now I is equal to 2. I'm taking this video to make you understand how it's working. That's what matters actually. So this is the new temp. This temp doesn't exist anymore. But the address of this node exists. Okay? Don't get the wrong idea that this node has been destroyed. This node exists at this part of head. He's not destroyed yet. So this new temp will have the value of A of 2, which is this 30. Again, tail dot next equal to temp. Whose tail now? This node is tail for now, right? Tail. Up till now he was tail. And he has the value to the next node. Tail dot next equal to temp. This is temp now, right? So that's the issue. Let me just do it again. This tail who had 20 and this new temp that I created will have 30, and this part tail dot next equal to temp. Tail dot next, that means tail's next will have him equal to temp. And then of course you know what happens, this will become tail, which is the increment of this part. Tail equal to temp, and then this part will not be reachable without head, but it still exists. So now the linked list has become head to a node which has, well, head has 10 itself, this node has 20, and then this node is connected to another node which is the tail. For now it will change, that has 30. In this way you can add 40 and then you can keep adding nodes, or you can just put it back to circular. So temp dot, once tail dot next is equal to head, that will become a circular linked list. That was the idea. Now back to coding. I hope you don't have any confusions of linked list now. Okay. So the first method we'll create, we do it for anything. Oh, one more thing. We need to create another construct. We need to create a constructor that will have set up the head, because that's ultimately the constructor. So public linked list it will receive a node. Note that the node class is over here. Okay, this is the node class. We are creating data type of this. So node, and all you have to do is set up the head. That's the only thing you need to do. Then again, you can make this an constructor as well. Array to list. If you are given an array and then you're told to create a linked list with this, this can be your constructor too. Now I'll just still name it, array to list. Now the first method we'll create is, of course, printing. What do I need to receive here? I don't need to receive anything over here because I have the head here already, so I don't need to receive anything here. So we need something like the tail, which will change. Okay, so node tail. And this tail must be equal to head. So we'll run a for loop. We have already set up the tail, so we don't need to do anything over here. And tail should not reach null. I'll explain this later. And tail will be incremented to tail.next. This would be the last explanation, I think. I need to give you. Hopefully after that you won't be having problems with linked list, at least on how it works. System.out print what's the thing we need to print? We need to print the element, so tail.element. There you go. And I need to make some modifications, so let's just put this over here. That's better. And I'm gonna make it even more beautiful, so okay, so we're done with this. Now once the printing is done, I want to end it with something like, it's completely unnecessary, but I'll still do it. Which is actually the last element. So let's put it like this. Okay, there are two ways to do this. I'll show you both ways. So let's just check out this way first. I hope there won't be any errors. Okay, we have the link list. Now we need to test all these things, so I'm going ahead and creating a public static void method. Okay, so I need to create a linked list first. So linked list L equal to new linked list. Is the name alright? Yep, it's fine. and I need a constructor. So and for this constructor, let's just use 10 and null and send that as the head of the list. Another thing I want to do is create an array of int Alright, so that's that. Now that we're done with this, let's try creating a linked list with that. So after we convert the array, we need to print the list to make sure it's working fine. So let me check everything. Now have one thing in mind: if we send this array to the linked list, then this head will be destroyed, and actually you can say replaced. So to have that, we need to put 10 over here to have that as your head. Then this part is not necessary actually. Let's just keep it null, and this is how we create an empty linked list. And oh, there's one mistake in this part. Okay, things are looking good now. Hopefully there won't be a problem. Alright, so there is no compile error. There could be runtime errors or some creative errors that we don't know. So let's hit run. Okay, static error, this class does not have a static void. Okay, to solve that issue, that's an easy problem. First thing we need to do is cut this static method and have it at the top. That means have it over here. And the second thing we need to do is replace this class, send it below. Things should be working fine now. And here's the list. So if you have an error called static class not detected, then this is how you solve it. Okay, so we have the list, it's working fine, but it's ugly. I can make it look beautiful. So that's how it becomes beautiful, and you can also add some more values. So there's the list. Now we have print list done, so we'll continue with other methods. For example, insertion, removing, and you will be told to count the number of nodes. Can you do that? Counting node is very essential, so I'll just show you. But one common sense is to count node, you need to go through all nodes, because this is not an array that you have a size and you can just say node equal to size. So we'll just copy this. Oh, I forgot to explain how we did this. Okay, I'm doing it now after I complete this one. Count list or list size, whatever you feel free to call it, doesn't matter to me. Okay, so we need a tracker, that's fine, but instead of printing, we need a value that starts from 0. We'll be returning this value, so we'll return an int. And as we go through the list, Z will be increasing. Okay, we don't need this, so this is the method. That's all you need to do. And there is another thing you can do. That sometimes you will be told to give the size. So if the element in the node is null, then you will not return size. But that's a complex thing. Let's just show you how it's done. So now I'm going to show you what's going on, and I'm going to pick a beautiful color. Blue. That sounds fine. Okay. So what's happening over here? I'm taking another node, which is tail. So head is holding 10. So I created another head. No, I didn't create an head. I created a node which is the same as head for now. Okay, until tail reaches null. Okay, when will tail reach null? So the list has this element. So there's L2 who has 20 and the address to L3 who has 30, or just assume 3, and then when the list ends, then you have null, which is the end of the list. This is not circular, so the last index or the last node will have no address, because that's the last index or the last slot. So it will have the address to null. So that's what I wrote, that when tail reaches null, while tail is not equal to null, you will continue. That means when tail reaches null, the printing should stop. Otherwise you will get a null pointer exception, because null cannot be printed. And tail will be tail.next. So tail is here now. After printing the tail.element, which is 10, tail will become tail.next. So now tail is here. So print 20, tail equal to tail.next. Now print 3, tail equal to tail.next. That's how it works. So 10, 20, 30, 40, null. So tail is here. Tail prints this, and tail.next, which is this. Tail prints this also, and then tail equal to tail.next. Tail equal to tail.next. Tail equal to tail.next. Oh dear, it's null. The loop stops. Okay, that's the idea. So when we're counting, we're doing the same thing, except of printing, we're just adding 1 to Z. So there's 1 element, 2 element, 3 element, 4 element. Null is not an element. Stop. So the answer is 4. That's the idea, and we'll use this mechanism for all linked list loops. Okay, so I'm not going to check that method now. We'll do that later. Now you would be told to find a node at a certain index. Let's go ahead and do that. So public, suppose you're told to return the element. So for our case, it's object node at or findNode an index. Okay, excuse me sir, this is a linked list. I don't have any index. Where will I get index? Of course you have index. Where do I have index, sir? Are you kidding? No, I'm not. You can count the list, can't you? You know the list size. So if you know the size, use that size to find the index. Sure sir, as you wish. So to do that, we need to count again, and when we reach that index, we'll just return the value. So once again, we need a tail, which is our bait, and it will be head as usual. Now one thing is, I don't want to waste my time. So if this index is 0, then I will actually print head. So in this case I'll just return head. So return if there exists any. Then again I could have done it using the count. So I just showed you sometimes to do this is a good practice to do the work of the head separately. So let's go. And one more thing, I still need to use if, because if the index is less than 0, that means they're trying to play with you. Don't forget to return null for that. And else, okay. One thing we need is once again the bait, the count. So in Z becomes reborn, so recreated or something, whatever, and we'll run the loop. So for where did we start from? Of course, tail. So we have tail equal to head. Once again we cannot let tail reach null, so tail equal to null. And tail will be jumping from one tail to another, so tail equal to tail dot. Just make sure when we reach the index, please be kind enough to return the value. So return you can do it for the head separately, you can do it like this as well. Now if this loop has completed, return when the method reaches return, the method ends. But if this loop has completed and nothing has been returned yet, that means that's an invalid index. For example, 100, 200, 300. So if that happens, I don't want to waste my space because the loop will go on, and so I will return null once this loop is over and nothing is returned. So that's it. And if the index is less than 0, then it will return run anyway. So that's how you find node. And then again you can also return the whole node itself. So just all you have to do is over here change return to done. So that's, we did two methods. What we need to do next is insert. Some similar methods you can do is get index. So this is the reverse. You will be given a node and once you find the node, you will have to return the index, which has the same mechanism as this. I think you can try that yourself. I don't need to do that, but I'm still going ahead and doing it. Okay, we need to do insert, we need to do removing, so I think it's better to skip that because you can do it. Listen, to find the index, you'll just have to run this loop where tail will be going, and then check if the tail matches the element you are given. When the two elements match, you will receive an element over here. When the two elements match, you're still counting, right? So return the count. So Z will be 1, 2, 3, 4, 5. At 5 you have a match, return 5. That's the thing. So it's very easy. You don't need to do it. I don't need to do it. Okay? So there's one more thing I need to do. We need to know how to reverse the list, because this is not an array. So how do you reverse a list? Okay, interesting, huh? Let's just write the name first. And for lists, you work with node, I told you. Reverse. The idea of reverse is I need to start from the end. So if I do that, I need to start from the end and then put the values reversely on this new list, and that is the only way I can get a reverse of this list. I cannot recreate the list. I have to create a list which is the reverse of that list. So to create a list means to create a node. So let's just create a node. Okay, now another node, which is the tail. As always we use it, a bait of the head. For now it will be empty with the element of head. Notice that I didn't write tail equal to head, so keep that in mind. It has the value of the head, not the whole head itself. And I need another node which is stem, like before, and let's keep it empty for now. We don't need that for now. So before I start, I want to tell you one last time what we are going to do. We cannot recreate the list in a way like arrays. So what we're trying to do is we are trying to create a new list, and then we'll put the reverse version of the linked list in this new list. So we're starting from the next value of head dot next, as usual, until it reaches null. This should continue, and x will be jumping from one place to another. So x equal to x dot next. Okay, now the tail part, who's going to do the work, will be created again and again. It will keep having the elements. And the reference to itself. This is the part where the list is reversed. Okay? Once you're done, all you have to do is return the new head you created, which is tail. Okay, this is the last method for today, and let me tell you one more time what we did over here. Get my pencils ready. We have the original head. That is where we'll start the loop from. However, what we did is, hey, I didn't need this. We don't need this, okay? What we did is we created a new node, that means a new list. There we had the element of the head, but we didn't refer it to the next element, that means head dot next. We started from head dot next. We went through the end of the list in the linear way, but over here even though we had the elements, the reference was to tail itself. So we changed the head. Let me clear it for you. Head, which is x, is changing. Previously we used tail equal to tail dot next. That's why the tail was changing and the list was moving forward. But this time head is changing, but tail is actually having its own reference. It's not dot next anymore. It's tail to tail itself. When the new tail is being created, the old tail has having the reference. This is where the list is reversed. I don't know if you understand this language, but okay, that's the idea. So I think we have done a lot for this video. Well, hey, how many brackets are there? I think this is an extra one. Okay, it's good. Now let's just see if it compiles. No, it doesn't. Oh, look at me, I didn't return that Z. Okay, so that's all for today, folks. You can after compiling, you can run your own experiment using these methods. You're quite used to that now. I've showed you in the previous videos that how you use the public static main void class to test out your methods. I hope you will be testing out these methods as well. And in the next video, we'll be doing with insertion removing. Until then, see ya. Happy surviving. All you need to do is survive.